Hi, this is Miss Buchel, and I'm going to be going over the 6B.7 notes, and we're going to be completing the square, which is changing a quadratic form from standard form to vertex. All right, and just to refresh, from standard form, we can easily get the y-intercept. It's our letter C. And in vertex form, I can easily pick out the vertex of the parabola. So before we get started on actually completing the square, or another phrase that you might hear it be called is CTS, we are going to review factoring. And I have this special trinomial, x squared plus 6x plus 9. So I'm going to start with my t-table. I'm going to find two numbers. My a is 1 and my c is 9. So I got to multiply those. So a times c equals 9. I got to find those same two numbers that I can add to get to 6. All right, and that is going to be 3 times 3, or 3 plus 3. I'm going to bust up my b term with plus 3x plus 3x. I have my first term, which is x squared, and my last term, which is 9. I'm going to factor by grouping. So I'm going to find the GCF between x squared and 3x, and that is 1x. I'm going to divide that x from each of the terms. So x squared divided by x is x. 3x divided by x is 3. I'm going to group the second pair and find the GCF, and it's going to be a positive 3. So I'm going to take out a plus 3. Divide 3 from each term. So 3x divided by 3 is x, and 9 divided by 3 is 3. Oh my gosh! They're the same thing. So we have 3, or x plus 3 as my first binomial. And if I look, my second binomial is also going to be x plus 3. So I could write it as two binomials, or I could write it as x plus 3 squared. This is a special trinomial because it gave me this repeated binomial. And they call these a perfect square trinomial. Because if I had a box or a square and each of my sides were the same, that creates a square. All right, so let's go look at number 2. I want to find the area of a field with a length x minus 4 and a width of x minus 4. All right. So again, my side lengths are the same. So this is really creating a square. All right. To find the area, we're actually going to multiply these. So I'm going to bring this width to the side, and I'm going to do box method. X and a negative 4. All right. When I'm putting numbers inside the box, I'm multiplying. So x times x is x squared. X times negative 4 is negative 4x. X times negative 4 is negative 4x. And negative 4 times negative 4 is a positive 16. All right, to write my final expression, I'm going to combine my like terms. So I have x squared, negative 4x plus negative 4x is negative 8x, and then plus 16. All right, this is another perfect square trinomial because again, we started with two binomials that are the same. So I'm going to kind of show you a little cool trick with perfect square trinomials. If I have x minus 5 times x minus 5, I can quickly create a trinomial. I'm going to have my x squared as my a term. I'm going to add the numbers. So negative 5 plus negative 5 gives me negative 10, and that's going to become my middle term. So that's with the x. I'm going to take these same two numbers, and I'm going to multiply them now. Negative 5 times negative 5 becomes a positive 25. This is a perfect square trinomial. So let's try another one. If I have x plus, let's do x plus 1 times x plus 1. So my first term is x squared. I'm going to add my two numbers. So 1 plus 1 is 2, so that's 2x. And then to find my c term, I multiply. 1 times 1 is 1. So another perfect square trinomial.